Okay, so this is the second video we've made on histograms. In the first video, we went through the basics of histograms and how they work. In this video, we're going to go through a bunch of past exam questions because there's quite a few different types, okay? If you want to have a go at any of the questions yourself, just pause the video before I go for the answer, okay? So for this question here, we're told a manager records the number of hours of overtime claimed by 80 staff in a month, and the histogram below represents the results. And we need to calculate the number of staff who have claimed less than 10 hours of overtime in the month for 4 marks. And we have this histogram here. Now, to do this question, what we first need to find is K, which is the scaling factor. So we talked about this in the first histogram video, is at A level, the area of the histogram and the frequency may not be equal to each other, they may be proportional to each other, and the area under the histogram may not be equal to 80. So we may need to find what the scaling factor is between the area under the histogram and the 80 staff here. So the way that we're going to do this is find the area of all 5 of these bars here. Now you'll notice they haven't actually labelled the y-axis here, and this is something quite common that they do in exam questions, and it's not really that big of a deal because we can just label it ourselves. So I'm just going to say that this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7, and this is 8. And you could label it differently if you want, and what's quite interesting is it would give a different value of K depending on how you labelled it, okay? So if we find the area of these 5 bars here, so let's start with this one. So the width of this bar between 0 and 2 is going to be 2. This is multiplied by the height, which is 8, and then 2 times 8 is 16. So the area of this bar is 16. If we look at this one here, so it's between 2 and 5, so the width is going to be 3, and this is multiplied by the height, and it comes up to 4, and 3 times 4 is 12, so the area is 12. For this bar here, the width is between 5 and 10, so the width is going to be 5, and this is multiplied by the height. Now it comes up to here, and you can see that this is going to be on our y-axis 1.2. So 1.2, which if you put into a calculator is equal to 6. So the area here is 6. And then for this one here, so we have a width between 10 and 20. So the width is going to be 10. And this is multiplied by the height. And it comes up to here. So this on our scale is going to be 0.4. And this is equal to 4. So the area here is 4. And then for this bar here, the width is between 20 and 30. So the width is going to be 10, and this is multiplied by the height, which comes up to here, which is going to be 0.2. So 10 times 0.2 is 2. So now we're going to add all these numbers together. So it's going to be 16 plus 12 plus 6 plus 4 plus 2. And if you put this into your calculator, this is equal to 40. Now we have 80 staff, so if we do 80 divided by 40, this is equal to 2, and this is the value of K. So for 1 unit of area in this histogram, it represents 2 staff, okay? So what we need to do, we need to find the number of staff who have claimed less than 10 hours of overtime. So this is going to be anything below 10 here, so it's going to be these 3 bars, so we need to find the frequency of these 3 bars here. So the way that we can do this, we know the area of these 3 bars. This one is 16, this one is 12, and this one is 6. So this is going to be the area, and we know the scaling factor is 2, so this here, we're just going to multiply this by 2. And if you put this into your calculator, this is 68. So this is the final answer. There are 68 staff that took less than 10 hours of overtime. Okay, so here's another past exam question where we're told the partially completed table and partially completed histogram give information about the ages of passengers on an airline, and there were no passengers aged 90 or over. And we need to complete the histogram and the grouped frequency table. So this is the grouped frequency table and this is the histogram. And this is actually quite a common exam question where they give you a grouped frequency table with frequencies missing or a histogram with bars missing, and you have to find out what they are. Okay, so in order to do this question, once again we first need to find K. k, which is the scaling factor. Now, the way that we need to do this is, so we can see, if we actually look at what we need to solve, so between 0 and 5 we have the frequency, but we don't have the bar, so we need to find that. Between 5 and 20 we have the frequency and we have the bar. Between 20 and 40 we have the frequency, but we don't have the bar. And then between 40 and 65 and 80 we don't have the frequencies, but we do have the bar. And for 80 and 90 we have both. Okay, so the way that we can find k is between 5 and 20. You can also do this for 80 and 90 as well. Between 5 and 20, because we know the frequency and because we also know the bar, so therefore we can figure out its area, therefore we can compare the area and the frequency in order to find out the scaling factor k. Okay, so let's do this. So once again, the frequency density is not labeled, so let's just label it ourselves. So let's say this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. Once again, you can label it however you want, okay? So this bar here, it has a width, so it's between 5 and 20. So I'm just going to write down that we're focusing on the 5 to 20 interval. So we can see that it has a width between 5 and 20, so it's going to have a width of 15, and this is multiplied by the height, and we can see that it comes up to 3. So 15 times 3 is equal to 45, and we can see that the frequency is also 45. So 45 divided by 45 is equal to 1. So this is the scaling factor. So this is actually an example where the area is equal to the frequency, and this is quite nice because it makes the question a bit easier to work with. Okay, once again though, depending on how you label the frequency density y-axis, the k value could be different. Okay, so let's start with the 0 to 5 interval. So this is this here. So we know the frequency is equal to 5, so that means the area is also going to be equal to 5. So we need the area of the bar to be equal to 5, and we know that the width is going to be between 0 and 5, so the width is going to be equal to 5. So therefore the height, as we know the area is 5 and we know the width is 5, 5 divided by 5 is 1, so this here is going to be the height of the bar 1. So therefore the bar is going to be this here. So this is the bar between 0 and 5. Okay, so now let's look at the 20 to 40 interval. So we know the frequency is 90, so we know the area is going to be equal to 90, and once again we know the width is going to be between 20 and 40, so the width is going to be between 20 and 40, so therefore the width is going to be 20. So therefore the area, which is 90, divided by the width, which is 20, is equal to 4.5. So this is going to be the height of the bar. So 4.5 is here. So this is going to be the bar. Okay, so now let's look between 40 and 65. So we don't know the frequency here, but we do have the bar, so we can figure out the area. So the width, so it's between 40 and 65, so the width is going to be 25, and this is multiplied by the height, and we can see that it comes up to here, and this is 5.2. So it's 25 times 5.2, and if you put this into your calculator, this is equal to 130. So this is the area, and as we know the scaling factor is 1, this is also going to be the frequency. So the frequency is going to be equal to 130, so it's going to be 130. And now we're going to look at 65 to 80. So this is the same as before. We don't know the frequency, but we do have the bar, so we can figure out the area of it. So it's between 65 and 80, so the width is 15, and this is going to be multiplied by the height, which comes up to 4, so this is equal to 60. So this is the area, so therefore the frequency is also going to be equal to 60. And therefore we have the final answer as 80 to 90. We already have the frequency and the bar. So this here is the final answer, and this is how you get the 4 marks. Okay, so a very common exam question that they like to ask is for you to estimate values using a histogram. So here's an example of this where we're told the histogram shows the distances in kilometres that 274 people travel to work, and we're given this histogram here. And given that 60 of these people travel between 10 kilometres and 20 kilometres to work, we need to estimate the number of people who travel between 22 kilometres and 45 kilometres to work for 3 marks. Okay, so let's just ignore this part for now. Let's focus on this part, that 60 of these people travel between 10 kilometres and 20 kilometres. And 10 to 20 kilometres is represented by this bar here. So using this, we can find the value for k because we can find the area of this bar here. So the area of this bar, so the width of it is between 10 and 20. So the width is going to be 10. And this is multiplied by the height. So this is another one of the examples where we're not given the y-axis, so we can just label it however we want. So I'm going to say that this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9, this is 10, and this is 11, okay? So using this, the height of this bar here is 3. So 10 times 3 is 30. So this is the area of this bar here. And we know that 60 people travel between 10 and 20 kilometers. So this is the frequency. So therefore 60 divided by 30 is equal to 2. So this is equal to k. So this is the scaling factor, okay? Now we need to find the number of people who travel between 22 kilometers and 45 kilometers. So the way that we're going to do this is 22 kilometers, if we look on the x-axis, is going to be here, okay? This is 22 kilometers, and 45 kilometers is going to be here, okay? So this is 45 kilometers, and we're essentially going to treat these as if they are bars in the histogram. So what I mean by that is we're going to find the area of this bar here and the area of this bar here. So if we start with this bar, so we're not including this section here of the 20 to 30 bar, we're only including this here where this is 22. Remember, this is 45. So the area of this bar here, so the width of it between 22 and 30, 30 minus 22 is 8, so the width of it is 8, and this is multiplied by the height, and if we look at our y-axis, this comes up to 1, so it's 8 times 1, which is equal to 8. So this is the area of this bar here. And if we look at this bar, so the width of it, so it's between 30 and 45. So 45 minus 30 is 15. So the width is 15. And this is multiplied by the height. And if you look at this height here, it comes up to, on our y-axis, 0.4. So 15 times 0.4 is equal to 6. So this is the area of this bar here. So 8 plus 6 is equal to 14. So this is the total area of this region. So therefore we need to multiply this by the scaling factor. So 14 times 2 is equal to 28. So there are 28 people is our estimate for the number of people who travel between 22 kilometers and 45 kilometers to work. Note, this is only an estimate, it's not the exact value, because we have kind of assumed that in these two bars here, the data is evenly spread all throughout the bars, which may not be the case. Okay, now a common exam question that they like to ask is for you to find the width and the height of a histogram bar. So here's an example of a question like this, where we're told the weights in grams of a random sample of 48 broad beans are summarised in this table here. So this is a grouped frequency table. Ignore the bits that I've crossed out in red here. This isn't relevant for the parts here, that's for later parts in the question. And we're told a histogram was drawn to represent this data, and the 2.1 to 2.7 class was represented by a bar of width 1.5 centimeters and height 1 centimeter. And for part A, for 3 marks, we need to find the width and the height of the 0.9 to 1.1 class. Okay, now there is a few ways that you can approach this question. I've seen a few different approaches that people do. The way that I do it, so firstly, we're told that the 2.1 to 2.7 class was represented by a bar of width 1.5 and height 1. So therefore, if we do 1.5 multiplied by 1, this is equal to 1.5. So this is the area of this bar. This is the area of the 2.1 to the 2.7 bar. Okay, now the 2.1 to 2.7 is here, and we're told it has a frequency of 2. So if we do 2 divided by the area, which is 1.5, this is equal to 4 over 3. So this here is the scaling factor, 4 over 3. Now one thing you need to distinguish here is this is the scaling factor for the area, and I'll come back in a moment as to why we need to make that distinction. Okay, so we know the scaling factor for the area, and we're looking for the width and the height of the 0.9 to 1.1 class, and we know that this class has a frequency of 9, so therefore we can figure out the area of this bar using this scaling factor. It's going to be 9 divided by this 4 over 3, which is equal to 6.75. So this is the area of the 0.9 to 1.1 bar. Make sure you get this the right way round. You're dividing it, not multiplying it by this 4 over 3 to get this area here. Okay, so this is the area of the bar. Now we need to get the width and the height of the bar. Now the reason I made this distinction about the area is we have another scaling factor for questions like this. We have the scaling factor for the width of the bar. So what do I mean by that? Okay, so let's look at this line here. So we're told that the 2.1 to 2.7 class was represented by a bar of width 1.5. Okay, so the width of this class here, 2.1 to 2.7, so it's 2.7 minus 2.1, which is equal to 0.6. So this is the width of this class here, and it's represented by a bar of width 1.5. So if we do 0.6 divided by 1.5, this is equal to 2 over 5. So this here is the scaling factor for the width of the histogram bar. And what we can do here is we can figure out the width of the 0.9 to 1.1 histogram bar, because what we can say, so we can see 0.9 to 1.1, 1.1 minus 0.9 is equal to 0.2, so this is the width of this interval here. So if we do 0.2 divided by this scaling factor here, 2 over 5, this is equal to, if you put it into your calculator, 0.5. So 0.5 centimeters is going to be the width of the 0.9 to 1.1 interval. So now we have the area of this histogram bar and we have the width of it, so therefore we can figure out the height of it, because we can do the area, which is 6.75, divided by the width, which is 0.5, which if you put this into your calculator, this is 13.5 centimeters. So this is the height of the 0.9 to 1.1 bar. And then this is the final answer. This 0.5 centimeters is the width, and this 13.5 centimeters is the height. I'm hoping that explanation makes some sense. Maybe rewatch it again if you don't completely understand it. And if you still don't completely understand it, there are quite a few examples in the book on a question like this. Question 6 and question 7 in exercise 3D, and question 5 and question 8 in the mixed exercise 3 are examples in which you need to find the width and the height of the 0.9 to 1.1 class. So maybe have a go at those to see if you can get the hang of it as well. Okay, I just want to quickly touch on part B as well, where it says give a reason to justify the use of a histogram to represent this data. And this is a question they've asked a couple of times in exams. So it's asking this data here, which is the weight in grams of some broad beans, why we can use a histogram to represent this data here. And we can do this because this data is continuous. We talked about what continuous data means in the data collection and types of sampling video, so go back to that if you need a reminder. The data is continuous and in a grouped frequency table. So this is why we can use a histogram in order to represent it, but this is the important part, that the data is continuous. Now, they could also ask you to estimate the median given a histogram. So here's an example of a question like this. So for this question, we're told the histogram summarizes the heights of 256 seedlings 2 weeks after they were planted, and we're given this histogram here. And we need to use linear interpolation to estimate the median height of the seedlings for 4 marks. Okay, so we did a video on linear interpolation, and we're going to use that method for this question. Now, for this question, you can do it using the histogram, but in my opinion, the easiest way to do this question is to convert it into a grouped frequency table and then use interpolation like we did in that previous video. Okay, so that's what I'm going to do. So we need to convert this here into a grouped frequency table. So first, we need to find K, the scaling factor, in order to get the frequencies here. So let's figure out the areas of these bars. So let's start with this one here. So the width between 0 and 1 is going to be 1, and this is multiplied by the height. We're actually given the axis this time, and the height here comes up to 15, so 1 times 15 is 15, so the area is 15 here. For this one, it's between 1 and 2, so the width is 1 and the height is 35, so this is going to be 35. And then here it goes from 2 to 3.5, so the width is going to be 1.5, and this is multiplied by the height, which we can see is 50, and 1.5 multiplied by 50 is 75. And then for this one here, it goes from 3.5 to 4.5, so the width is going to be 1, and this is going to be multiplied by the height, which comes up to 55, so this is equal to 55. And then for this one here, it starts at 4.5 and it ends at 6.5, so the width is going to be 2, and this is multiplied by the height, and you can see that this comes up to 26. So 2 times 26 is 52. And then for this one here, it starts at 6.5 and ends at 8, so the width is 1.5, and this is multiplied by the height, which we can see here comes up to 16. So 1.5 times 16, which is equal to 24. So this here is 24. So if we add these areas together, it's 15 plus 35 plus 75 plus 55 plus 52 plus 24, and if you put this into your calculator, it's equal to 256, and this is the same number as the frequency, the 256 seedlings. So 256 divided by 256 is equal to 1, so this is equal to K. So this is quite a nice example where the area is equal to the frequency. So if we convert this into a grouped frequency table, so firstly we're going to have the classes. So the class, so this one here goes from 0 to 1, this one goes from 1 to 2, this one goes from 2 to 3.5, this one goes from 3.5 to 4.5, this one goes from 4.5 to 6.5, and this one goes from 6.5 to 8. Now the frequency is going to be, so as we said, the frequency is equal to the area, so the frequency of this one is going to be 15, it's going to be 35, and then 75, and then 55, and then 52, and then 24. So this is the grouped frequency table here. Now, in order to do linear interpolation, as we talked about in that video, we need to find the cumulative frequency. So I'm going to note this with CF. So it's going to start at 15, and then 15 plus 35 is 50, and then 50 plus 75 is 125. 125 plus 55 is 180, and then 180 plus 52 is 232, and 232 plus 24 is 256. So these are the cumulative frequencies. Okay, so remember how to do interpolation. So we're trying to find the median. So here, the total number of data values is 256. So n is equal to 256. To find the median, we find n over 2. So this is 256 over 2, which is equal to 128. So this is the data value that we're trying to find. Remember, when we're doing linear interpolation, we don't round this value in any way. We keep it as 128. So if we look at the grouped frequency table here, 128 is going to be in this class here, 3.5 to 4.5, okay? So when we're doing interpolation, as I talked about in the interpolation video, I like to draw a diagram like this here. I'm just going to move this up slightly. So this diagram, so if we look at this interval between 3.5 and 4.5, it starts at 3.5 and it ends at 4.5. And if we look at the cumulative frequencies, it starts at 125 and it ends at 180. Now we're looking for the 128 value. Between 125 and 180, 128 is going to be right at the beginning. It's going to be, let's say, it's here, 128, and we're trying to find this value in the interval. Now what we're going to do is we're going to take away 125 from all the frequencies here. So this now starts at 0, this frequency, and this 180 is now going to be 180 minus 125, which is going to be this 55 here. And then here, if we do 128 minus 125, this is equal to 3. So this 128 is going to be 3. So we have this 3 here between 0 and 55. We want to find how far across this line is 3 is. So we're going to do 3 divided by 55. So 3 divided by 55, which if you put this into your calculator is equal to 0.0545. So this is the proportion of how far across this line 3 is between 0 and 55, and it's going to be the same proportion on this side as well. So this interval starts at 3.5 and then we're going to plus this 0.0545 and we're going to multiply this by the class width, and the difference between 3.5 and 4.5 is 1. So this, if you put this into your calculator, is equal to 3.55 centimeters, and this is the median height of the seedlings. Again, go back to the linear interpolation video that we did where we talk about this method further. Okay, so here's another question where we're told the histogram shows the time taken, t minutes, by each of 100 people to swim 500 meters, and we're given this histogram here, okay? And for part A, we need to use the histogram to complete the frequency table for the times taken by 100 people to swim 500 meters, okay? So you can see we have these two entries missing that we need to find, okay? So first, we need to find K, and we can do this because here we're told, so for example, you can use any three of these entries here, but for 5 to 10, for example, we know the frequency is 10 and we can see the bar here, so we can figure out the area of the bar and therefore find K, okay? So if we look at this bar here, so the width is between 5 and 10, so the width is 5, and this is multiplied by the height. Now this is unlabeled, the y-axis. I'm just going to say that this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, and this is 8. So it comes up to 2, so it's 5 times 2, which is 10. So this is the area, 10, and we can see that this is also the frequency. So 10 divided by 10 is equal to 1, so it's equal to K. So this is one of the nice examples where the area is equal to the frequency, okay? So we need to find the frequencies for 18 to 25 and 25 to 40. So let's start with 18 to 25. So this is this one here. So the width, so it's between 18 and 25. So this is going to have a width of 7, and this is multiplied by the height, and it comes up to 5, and this is equal to 35. Remember, K is equal to 1, so this is also the frequency. So the frequency is 35, and then for this one here, so the width between 25 and 40 is 15, and this is multiplied by the height, which is 1, so 15 times 1 is 15, so therefore the frequency here is 15. Okay, and then for part B, we need to estimate the number of people who took less than 16 minutes to swim 500 meters. Okay, so 16 minutes on this diagram is here. So we need to find the frequency that is less than this. So we have these two bars here, and we know these have a frequency of 10 and 16, so we can just add these together. And we also have this half bar here. Okay, so we can find the value of this. So the width of this, so this starts at 14, remember this interval, and it ends at 16. So 16 minus 14 is 2, so the width is going to be 2, and this is multiplied by the height, and this bar comes up to 6. 2 times 6 is 12, so the frequency of this half bar here is 12. So therefore, if we add the frequencies together, it's going to be these two bars, which are 10 plus 16, and then plus this half bar, which is 12. And you add these numbers together, it's equal to 38. So this is the number of people, the estimate of the number of people who took less than 16 minutes. Okay, and then for part C, we need to find an estimate for the mean time taken to swim 500 meters. Now, this is similar to the example from before, where we're not going to use the histogram here. It's a lot easier to use the grouped frequency table. And if you're ever in a situation where you need to estimate the mean for a histogram, I would recommend converting it to a grouped frequency table, as it makes the question a lot easier. So we talked about how to estimate the mean for a grouped frequency table in the measures of central tendency video. So go back to that if you need a reminder. The way that we're going to do it is we need to find the midpoints of all of these intervals here. So the midpoint for 5 and 10 is 7.5. The midpoint for 10 and 14 is 12. The midpoint for 14 and 18 is 16. The midpoint for 18 to 25 is 21.5. And the midpoint for 25 and 40 is 32.5. And to make the estimate, we're going to assume that all of the data values in these intervals are equal to the midpoints. Okay, so remember what the mean is. So the mean, so this is the notation for the mean, is sigma x, which is all of the data points added together divided by the number of data points. Okay, so sigma x is, so we have 7.5, and this occurs 10 times, and then we have 12, and this occurs 16 times, and then we have 16, and this occurs 24 times, and then we have 21.5, and this occurs 35 times, and then we have 32.5, and this occurs 15 times. And if you add all of these values together and you put this into your calculator, this is equal to 1891. Okay, now n is equal to the number of data points. You could add these frequencies together, however, we're just actually told in the question there are 100 people in this data, so therefore n is equal to 100. So therefore the mean is this 1891 divided by 100, which is equal to 18.91. So this here is the mean time taken for the people to swim 500 meters. Okay, and then we're given that sigma ft squared is equal to 41033. And for part D, we need to find an estimate for the standard deviation of the times taken to swim 500 meters. Okay, so we did a video on standard deviation, so go back to that if you need a reminder on how it works. This sigma ft squared, as I talked about in that video, you can kind of just ignore the f. The f essentially just means it's in a frequency table. It doesn't really mean much. The t, in part C, I called the data x, but technically the data should be called t, but it doesn't really matter that much. So this is saying that sigma t squared or sigma x squared is equal to 41033. Now, if you remember the formula for variance, so variance is equal to sigma x squared over n minus sigma x over n squared, or in other words, it is the mean of the squares minus the square of the mean. Okay, so therefore the variance is sigma x squared, or sigma t squared if you prefer, and we're told that this is equal to 41033 divided by n, which, as we talked about, n is equal to 100, so divided by 100 minus this here, sigma x over n, which is the mean, and we figured out in part C that the mean is 18.91, so we can just sub this in as 18.91, and then it's the mean squared. Now if you put this into your calculator, we get that the variance is equal to 52.7419. So to get the standard deviation, we square root the variance. So we square root this 52.7419, which if you put this into a calculator to 2 decimal places is 7.26. So this is an estimate for the standard deviation. Okay, so here's one final question in this video for you to have a go at. I just want to mention one thing quickly, because I haven't discussed this in this video yet, although I did mention it in the previous video on histograms. This is quite a common thing that they do in questions, is here the intervals, they have rounded them to the nearest minute. So we have 4 to 6, and then we have 7 to 8, and then we have 9, and then we have 10 to 12. And this does impact the size of the intervals because of the rounding. Just bear that in mind if you're going to have a go at this question. So have a go at the question, pause the video now, and I'll go for the answer in about 5 seconds. Okay, so for this question, we're told the partially completed histogram and the partially completed table show the time to the nearest minute that a random sample of motorists was delayed by roadworks on a stretch of motorway. Okay, so we have this histogram here and we have this grouped frequency table, and you can see that for the frequency table we have frequencies missing, and for the histogram we have bars missing here. And we need to estimate the percentage of these motorists who were delayed by the roadworks for between 8.5 and 13.5 minutes for 5 marks. Okay, so I just want to mention again this rounding part to the nearest minute, and this is important because this affects the final answer, because these here are not the true intervals if we're rounding to the nearest minute. So for example, if we look to the 4 to 6 interval, you can see we have this bar on the histogram. So 4 minutes is this line here and 6 minutes is this line here, and you can see that this histogram bar actually starts a bit before 4. It actually starts at 3.5 and it ends after 6. It ends at 6.5, and this is because of the rounding. The true interval of this 4 to 6 minutes here is going to start at 3.5 and it's going to end at 6.5, because if we're rounding it to the nearest minute, 3.5 when you round it is going to be 4. So this here, because we're rounding to the nearest minute, is the true interval. It's going to be the same for this 7 to 8, so it's going to start at 6.5 and it's going to end at 8.5. Then this 9 here is going to start at 8.5 and it's going to end at 9.5. This 10 to 12 is going to start at 9.5. It's going to end at 12.5. This 13 to 15 is going to start at 12.5 and it's going to end at 15.5, and this 16 to 20 is going to start at 15.5 and it's going to end at 20.5. Okay, so in order to do this question, let's first complete the histogram and complete the table. Okay, now the 4 to 6, and we also have it for the 13 to 15, we have the frequency and we also have the bar in the histogram, so we can use this in order to find k. So let's do this for the 4 to 6. So for the 4 to 6, so the area, so the width, so it starts at 3.5 and it ends at 6.5. So the width is 3, and this is going to be multiplied by the height. This is another example where we're not actually given like the axis, we have to make it ourselves. So let's say this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9, and this is 10. So we can see that the height here is 1, so it's 3 times 1, which is equal to 3. So this is the area of this bar here, and you can see that the frequency is 6. So 6 divided by 3 is equal to 2, so this is k. Okay, so therefore we can figure out the frequencies here. So the 7 to 8 bar is this here. You can see it starts at 6.5 and it ends at 8.5, so therefore the width of it is going to be 2, and this is multiplied by the height, and you can see that it comes up to 3.5. So it's 2 times 3.5, which is equal to 7. Now k is 2, so we need to do 7 times 2 to get the frequency, which is 14. So the frequency here is 14, and then to get the 16 to 20 here, so the 16 to 20, so it starts at 15.5 and ends at 20.5. So the width is going to be 5. This is multiplied by the height, and you can see this comes up to 0.5, and 5 times 0.5 is 2.5, and then 2.5 times 2 is equal to 5. So the frequency is 5. So now we need to find the bars. So we need to find the bars of 9 and 10 to 12. So let's start with 9. So the frequency is 17. Now remember, k is 2. So we're going to do 17 divided by 2, which is equal to 8.5. So this is going to be the area of the bar. Now the width of the bar is between 8.5 and 9.5, so it's going to be 1, the width, so 8.5 divided by 1 is equal to 8.5, so this is going to be the height of this bar 9 here. So if we draw this on, so it starts or it ends at 9.5 like this here, and it's going up to 8.5 like this here. So this is going to be the bar for 9, and now we're going to focus on the bar for 10 to 12. So the frequency is 45, so 45 divided by 2 is equal to 22.5, so this is going to be the area. Now the width is between 9.5 and 12.5, so it's 3, so it's going to be 22.5 divided by 3, which is equal to 7.5. So this is going to be the height of the bar. So it's going to come up to 7.5, which is here like this. So this here is going to be the bar for 10 to 12. So we've completed the histogram and we've completed the grouped frequency table. Okay, so we need to estimate the percentage of these motorists who were delayed by the roadworks for between 8.5 and 13.5 minutes. So if we look at the histogram, 8.5 starts here, and 13.5 is here. Okay, so we're interested in this area here. Now we have this bar here, which is the 9 bar, and we know this has a frequency of 17, and we have this bar here, which has a frequency of 45. Now we have this here, this kind of bar that we have drawn on ourselves, which starts at 12.5 and ends at 13.5. So it's going to have a width of 1, and it has a height of 1.5. So the area of this kind of mini bar here is going to be 1.5. Now the frequency of it, as k is equal to 2, the frequency of it is going to be 1.5 times 2, which is equal to 3. So this here has a frequency of 3. So therefore the frequency of this section here is going to be the frequency of this bar, which we know is 17, plus the frequency of this bar, which we know is 45, plus the frequency of this bar here that we've drawn on, which is 3. And if you put this into your calculator, this is equal to 65. So this is the number of motorists who were delayed by the roadworks for between 8.5 and 13.5 minutes. We need to find the percentage, and we can do this because we can just add all of these frequencies together to get the total number of motorists. So the percentage is going to be 65 divided by these frequencies added together, so 6 plus 14 plus 17 plus 45 plus 9 plus 5, and we want a percentage, we're going to multiply it by 100. And if you put this into your calculator to one decimal place, is 67.7%. So this is the percentage of the motorists who were delayed by the roadworks for between 8.5 and 13.5 minutes.